Okay, so this lesson we're looking at Pythagoras' theorem. So in Pythagoras' theorem, we remember that it can only be used on a right-angled triangle. So you have to know that it's a right angle if you are going to use Pythagoras' theorem. And remember when you're labeling up the diagram that the C, or the hypotenuse, is always the one opposite the right angle, and it is also the longest side. So it's the longest side because it's opposite the biggest angle. So you can't have a right angle triangle. There will be no other angle bigger than 90. So that's the opposite, the biggest side. Sometimes they ask you to find the side length of the opposite, the smallest side, and that will be always opposite the smallest angle if you get asked that. So anyway, you've got Pythagoras' theorem. So let's do this one. It says find the value correct to 2 decimal places. So you need to be really careful now. You need to start highlighting this because in the last SAC I noticed people are getting lazy. It said to 1 decimal place. So even if it's ends up being a perfect answer of 16, you need to write 16.0. So you've got to be careful. All right, so you would have labelled this triangle up and you go, this is C and this is A and B. And what you can simply do in your calculator, because we want you to do the less calculations, the better. That's the less amount of mistakes. So you write out the formula, which is x squared equals 6.1 squared plus 5.3 squared. And then on your calculator, you can use your solve function. You can go solve, comma x, and you'll find that x is equal to 8.08. Okay, so it became 8.08 centimetres. Just be careful too. You need to make sure all the units are the same before you use a formula. So they were in this case, and make sure that you state your units in your answer. Okay, so we're going to do a couple more examples. So here again, if you were labeling up this triangle, this is your C and A and B. And so if you write out the formula, it would be 8.6 squared equals 5.6 squared plus y squared. And once again, you can just put the solve into your calculators, comma y, and make sure that it said 2 decimal places, and also checking that the units were the same, which they were, before we finalize our answer. And when we do that, we end up with y equals 6.53 centimetres. Okay, so there's 2 decimal places. Be careful now, you have decimal places or significant figures. It could be either way. Okay, find the area of a square with a diagonal length of 6 times square root 2. So it's always good, if they haven't got a diagram, draw a diagram for yourself. So you've got a square, and what they're saying is that the diagonal length is 6 square root 2. And now they're saying find the area of a square. All right, so the area of a square, if you look at it, you've got the side length. So area would equal x times x, or x squared, yeah? So what do you know? You can use this Pythagoras theorem here. So I could say this is C, and this is A, and there's another one, there's B. So what I'm going to use is that triangle like that. And because I only have one unknown, I can work it out. So I just plug it in. It would be 6 square root times square root 2 squared equals x squared plus x squared. Okay, now you can still use solve, and you can see how we want to know what the area is anyway. So let's just say comma x squared, so we don't have to worry about squaring it at the end. So if we did that, we get, oh, no, it didn't like me. It doesn't like you, it doesn't like, the calculator doesn't like that. So just do comma x. We work out x equals 45. Wait a minute, no, sorry. X equals 6. So we've got x equals 6, so therefore the area would be equals 6 squared, which equals 36. And just check, it didn't have any units, so we'll just say 36 square units because they didn't say any measurements, so just say that. All right, so that's that one. Now sometimes you get these chord questions with the circles, and you need to be aware that often it's got Pythagoras in there. So just to show you this one here, example 4, it goes in the circle of center O, the chord AB is of length 10 centimeters. So they're saying that that is the 10 centimeters. If the radius of the circle is 13 centimeters, so what they're saying there, the 13 centimeters radius, that's that line going down there like that. So find the shortest distance from the chord to O. So the question that they're asking, the shortest distance, is actually you want this little bit in there, okay? Now, can you see what they're doing is they're going to use this triangle here, okay? So if I just draw that out over here, I've got O, and I go out to A, and then I've got down to the center. So this is the halfway, along here is the halfway along that chord. So they said that chord was 10, so what if I'm only going halfway, it would be 5. Okay, now if I'm going from here to the edge, if I go from the center of the circle to the edge of the circle, isn't that the radius? Yes? So therefore, I know that this distance here is also 13 centimeters, isn't it? Yeah? Any bit from the center to the edge is 13. Now we can see a little right angle triangle, and x is what I want to know there. Yeah? So I can just do the same. So to me, that's C, and that's A, and that's B. So I can write out Pythagoras and say 13 squared equals x squared plus 5 squared, and I can do the solve. Over here, on their explanation, they're doing the manual way. Just do solve, don't worry about it, and x. And it said, it didn't say how many decimal places, but they went to 80. Oh, wait a minute. This is not the answer to this, is it? Not even the right numbers. Sorry. So, I don't know where that came from. Oh, that must be over here. Sorry. Yeah. All right, so we've got to actually fix this one up. So we've got to solve that on our calculator. All right, so we got that x equals 12 when you do that. X equals 12, and it was centimeters, so that's fine. And that's less than the radius, which is good because it should be. All right, over here on this one, the diagonal of a soccer ground is 130. So just again, if you need to draw the diagram, so they're saying that is 130, and they said the long side of the ground measures 100, so that's 100, and then they said find the shorter side, so that means the x. So you can see there, they've shown you, but you can just use your solve again, and 130 is your hypotenuse, and you can just have x squared plus 100 squared comma x, and you'll get x is 83.07 centimeters or meters, whatever it was. Okay, so that was that one done there. So this one is also taken from an exam. It's either going to be 2017, 16. I did chuck a few 18s in there from last year when I saw them, when I was getting your notes together. So very recent, this one, I can tell. So if you have a look again, it's question 2, so it's not going to be too difficult. And if you have a look, it's asked the right angle triangle XYZ has the lengths blah, 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 as shown in the diagram. Now it says calculate XZ, so they want this line there. So you can see you've got Pythagoras, and that would be C, A, and B. So you would just pop in your calculator again, just go call that one X then, solve, and it'll be X squared equals 38.5 squared plus 24.0 squared, comma, X. Once again, I'm quickly checking, I probably should do it, that they're both centimeters. Yeah, if it wasn't, you would have to change that. You've got to use the rule, has to be in the same. So if you type that into your calculator, you'll get X equals 45.4, and that's D. So that's pretty good. See, that's question 2, so it's pretty easy. You would have already been able to do that. Hopefully our Year 9s could do that question. All right, let's do this one. A cubic box of side length 36 centimeters is to contain a thin straight metal rod. The maximum length of this rod is closest to. They love this question, and you guys would have already done it. So I'm going to draw it for you. So they're saying a cuboid, which means like that, like a box of side, and because it's a cuboid, that means they're all the same length, yeah? And they're saying that's 36. Now, what they're saying is that you can get a rod that goes from, wouldn't the biggest rod go from one corner out to that back corner out there? Yeah. So what you're going to do is you need to create the triangle. This is all Pythagoras. Now, if you think about it, it would run across the diagonal of that base of that box. Can you see that? So this would go like that, yeah? So we've got the rod going along the diagonal. We've got this, I'll just show you. So this is the right angle triangle that we're going to use, we're going to need. So if I just draw that, so it's where I have the red base, the red base floor. I've got the side length, which I know is 36, and I've got the rod is what I want to know. So I'll just call this R for rod. Okay, I at the moment don't know what this one is here, and I need that one to be able to do Pythagoras. Now, can you see down on the floor of the triangle, the box, sorry, I can get another right angle triangle there, can't I? I can go those two guys, which are 36 because they're the length. And then can you see I've got that red line running across the bottom, and that's X. Can you see this? Some people find this hard to see. So this one is on the floor of the box. Yeah, this is the rod, this is sort of the 3D triangle, yeah? That's the floor, that's the side, and that's the rod, okay? So this flat triangle is in here, that's an actual right angle there. So you can use Pythagoras to find out what X is. So X squared equals 36 squared plus 36 squared. And we might use the solve, comma X, and we're going to work out what X is. Okay, so we get that's 50.9 centimeters. So now I've got X, I can put that over into here. So now when I'm finding the rod, I'll have R squared, because that's the hypotenuse, equals X, this one, X, so 50.9 squared plus 36 squared. And you can do solve again and find out what R equals. Okay, so R ends up being 62.5 centimeters. Okay, so there is a 3D one for you. You'll get them later on as well. We'll practice them a bit more later on, but just so you can think about it now. You would have done them in other classes, previous years. Okay, in the triangle ABC, the length BC is equal to, so they want this length here. So really, you can see if this is can you see that this is an isosceles triangle? So if I calculate that length there and times it by 2, that will tell me the whole length. So I'm going to use this right angle triangle in here, and I'm just going to use that. So I'll go 14 squared equals 8 squared times this one, which plus x squared, and I'll just do solve, comma x. I'll get what x equals. Okay, x equals 11.5. And yeah, and then the answer, we have to times it by 2. So 11.5 times 2 equals 23 centimeters. Or meters, sorry. Yeah. So there's our answer for that one in there. Okay, so here's another one of that depth thing as well. So it said this time they want to find the cross-section of a water pipe, and it's circular with radius of 50 as shown. The surface of the water has a width of 80 centimeters. The depth of the water could be. So it was similar to the one before, except if we go like here to here, you know that's another radius, isn't it? So that blue line is 50. What they're actually asking you for is this from here to here. That's the question, okay? Now, if you know that whole bit is 50, can you see if I find out just what this little bit is? So I'll call that x. Would you agree if I said 50 minus the x, would that not equal the depth? Are you happy with that? Yeah? So if you say that, so that's all right. So you're happy with that. Now, what the triangle I'm going to use to do that is this one in here. Sorry, this one here. Yeah? So I'll draw that for you. I've got the x, that's what I'm trying to find, down to there, which is, this is a radius, so that's 50 centimeters. Now remember they said that this chord, or the length across, is 80. So if you're breaking it in half, how long is that bit? That would be 40 centimeters. Can you see where I got that from? The 40? So I'll rub out a bit of this so you can tell. So what I'm saying is that you're splitting this 80 in half, so you know this is 40 here. So I know that's 40 there. So now I can use Pythagoras to find x. So I can say 50 squared equals x squared plus 40 squared. And I can do the solve. And I can find out what x is. So x ends up being 30. So therefore, 50 minus 30 equals the depth, which is 20 centimeters equals the depth. All right, so let's have a look. We've got a square-based pyramid, which they've called the alphabet, shown below, and the sides of the bases are 7 centimeters and the slant is 8 centimeters. The vertical height of the pyramid is closest to. So if we first look at what we want, the triangle that we would use here to find the height is going to be that triangle there. Okay, so if I look, I'm just going to colour that one blue though. All right, so if I draw out that triangle, I have H is what I want. I know that's 8 centimeters, and I actually have this line going across here, which I might just call X. So I don't know what X is. So this is a right angle triangle, and I need that side X so I can work out H. Now, can you see if I use this big triangle, right angle triangle like that? So when you have a square base pyramid, you can use the bottom as a right angle triangle. So what that one is you've got a side and a side, so that's 7 centimeters and that's 7 centimeters, and then you've got this long side running through. Now we only actually need half of it we called X, but wouldn't that also be X if I'm saying from here to here is a distance of X? All right, so I'm going to say that. So you need to find out what X is. So you can actually use Pythagoras. You could just write that you've got 2 X's there. So you can actually say that 2X squared is equal to 7 squared plus 7 squared. And then use your solve, comma X. Let's find out what X equals. Okay, so X ends up being 4.9. Okay, and then you're going to take that and put it into here. So then you can solve that one, and you can say 8 squared equals H squared plus 4.9 squared. And then you solve again, and you get your answer for H. So, okay, and I get H equaling 6.3 centimeters. So it's a 2-step question. It will be a more difficult question, but yeah, and you have to do it in 2 steps like that. Okay, and this last one, the hemispherical bowl. When they say hemispherical, it means it's exactly half a ball, like a sphere. Has a radius of 10 centimeters as shown. If the bowl contains a maximum depth of 2 centimeters, the radius of the surface of the water in centimeters is. So if you think about it, it's a little bit like that chord question here. That radius is going to be that distance from there to there. And remember how they said before it was like you had a chord and they said that was 80 or whatever? So you know you're trying to actually find just this little bit here, in here, and we'll call that X. Now, you know that from the center of a circle down to the edge is also the radius. So you already know that from there going through that is also 10. Okay? Now, also, if that's 10 from there to there, but they said the depth is 2. So what is this little bit in here? 10 minus 2 would make 8. Now, if I'm going from the center of the circle, am I not going out to the edge of the ball there when I go out to that corner? I am, aren't I? So that would also be 10. So if I drag out this triangle of what I've found, they want me to find this X. So I'm saying X equals the radius of the water, of surface water. Okay. So I've got X there, and I've also found out that that little distance here and here is 8. I've got it right, and I know that's 10. So we can use Pythagoras, can't we? Yeah? So we can say 10 squared equals 8 squared plus X squared, and we're going to solve, comma X. We got X equals 6 centimeters, which is answer B. That is question 6, yeah? And there's only 8 questions. It's going to be a tough one. So it would have been tough. You might not have been able to get that, but I've explained and shown you how to do it. So watch it when you're revising.